when number of students is less. ઓછા ડબ્બાવાળી ટ્રેન ફટાફટ ભાગે બરાબર ને ઓકે સો Stokes law. So what is Stokes law? Have you ever noticed that, like, you take a badminton front box and you hit it? First it moves very fast, and then it starts getting slower. Why do you think it becomes slower? Due to air resistance. Very good. So Stokes law is one of the special cases of that air resistance or any other fluid resistance. Air is a fluid, right? Any other fluid resistance. So whenever Stokes law is actually for whenever some sphere moves with a speed v in a viscous fluid, whenever some sphere moves with the speed v in a viscous fluid, there is an opposite resistive or viscous force. This is also called viscous force because it is due to viscosity. So there is an opposite resistive or viscous force on the sphere, right? And how much is that force? That is equal to Fv or Fr, resistive force of the vessel. Fv is equal to 6 pi eta Rv, where Fv is that force itself. Okay, Fv is the resistive force or the viscous force. 6 and pi, the numbers. Eta for coefficient of viscosity, R for radius of that sphere, radius of the sphere, okay, radius of the sphere, and V for speed of the sphere. Now you see there is really no derivation of this. Out here they have no proof. In fact, that is why it is called a law. Generally, in physics, whenever something is named a law, what it means is that it's not wrong, but it has been observed, but there is no theory behind it. For example, Newton's laws of motion. Right? They are true by observation. They are empirical. If you remember, I told you that word. They are empirical, right? Okay, just like that, Stokes law is also empirical to quite an extent, right? But still, we are going to do some bit of dimensional analysis, right? So that will help you understand what kind of relation we have here. So suppose I want to dimensionally compare force, coefficient of viscosity, radius, and speed or velocity. I write it here, you can write it below, whatever you have written. Fv vector is minus 6 pi eta Rv vector. Do you see the difference between these two? Yes. This is magnet. And here we are writing it in vector form. So what have I changed? I have put a minus sign. What does that mean? It means the viscous force or this resistive force is opposite direction of velocity. Right? So for example, let's say, if we consider that you have hit a small ball or anything like a sphere, let's say its velocity is downwards, then this force on it will be upwards. That is, the air or the fluid in which it is moving will try to resist or oppose its motion. But that fluid is going to push it upwards. If it moves towards the right side, however it moves, it will oppose. Right? Okay, so that's the thing with the resistive force. all resistive forces, all kinds of resistive force, all resistive forces are always opposite to velocity. I common property. Understood? For example, think of kinetic frictional force. Kinetic frictional force is also opposite to the relative velocity, if you remember. Right? Same thing here. Okay. So now we'll just do a little bit of dimensional analysis. Hopefully you remember things. Right? So force, if we say that it depends on eta, on radius and on speed. Okay. You still remember it? चलो कोई वाला नहीं फटाफट के बाहर नहीं लगे तुमने तो इक्वेशन सॉल्व करा so dimensionally this should be equal to things so dimensions of force are m raised to 1 l raised to 2 t raised to minus 2 so that should be equal to dimensions of eta do you remember dimensions of eta Pascal second say the pressure into time करो तो सही जाए what is pressure m raised to 1 l raised to minus 1 t raised to minus 2 into second મને pressure है यार I'll be very honest પણ તમને ખબર નહીં પડી હોય મેં લખી રાખ્યું બનાવીને એટલી વાર કે the pressure is force upon area force એટલે એ નો યાદ હોય તોય કઈ વાંધો નહીં force is mass into acceleration upon area જો કેટલી વાર લાગે સમજી ગયા કે નહીં એટલે બહુ યાદ આવે જરૂર ન હોય just remember some of the basics like mass length time ની બધા તો આવડે and then very simple ones like velocity acceleration and maybe force work and energy but energy આગળ ન જાવ તો ચાલશે everything else you can make right if you remember formula okay formula તમે યાદ રાખવી જ પડે નહીં તો સમ થવાના છે અને સર લખવા આપી દીધું so this is what is theta's dimension now raised to a now then length or radius is a length એટલે l raised to b and then similarly over here velocity that is l raised to 1 t raised to minus 1 this is we can solve for by making three equations I'm just trying to make you recall what you have studied right three equations that is compare power of m so 1 is equal to 1 into a that is a put the okay or not okay just like that compare powers of l now 1 is equal to minus a plus b plus c I hope you all remember that when you multiply the power gets added so एक भी equation बनी गई and now just like that for t so minus 2 equal to minus a because this is ultimate minus and then minus c so a ની વેલ્યુ અમે મૂકો c આવી જાય a b ની a અને c ની વેલ્યુ અમે મૂકો b આવી જાય okay but I will not that fine so if you do it like this what will ultimately happen is you get a is 1 b is 1 and c is also 1 get out 2 આવી જાય you get that f should be equal to eta rv right but a limitation or a problem with this method is you can never find that constant okay because constant a number like this is a number does not have dimension so this does not allow you to explore what's this number but then that's not a big deal you can do it by experiment suppose you take some sphere with some known size okay and you allow it to fall with some speed and you take water let's say then water has a known coefficient of viscosity you find out how much force is acting so to measure કરી નાખો તો આ constant મળી જાય right so you can do it like that so this is what is Stokes a sentence okay so if you just want to remember the formula this is it. Again don't forget what I have drawn in this diagram and if it's moving in one direction then the resistive force is in opposite direction and this is only valid for sphere mind you suppose if there is a cube falling in water then this is not applicable radius kya leva jata understood what I said so this Stokes law it was found by Stokes that's why it's called Stokes law okay so this Stokes law is only valid for sphere right for different shapes the relation would be different right but this is one of the simplest versions right for such a force that's why we have it okay so that's about it right now based on this we are going to derive terminal velocity okay I'm going to raise Alright? Again, it's not just about air, it's any fluid, any kind of fluid, there will be resistive force. So terminal velocity or terminal speed of freely falling sphere. Terminal velocity of a freely falling sphere. Have you seen the movie G.I. Joe Rise of the Cobra? How many of you have seen that movie? Right. So, others not fan of English movies? Never mind. Why does that? Why am I recollecting that? Because in that movie there is a scene which violates this principle, right? કારણ કે સાયન્સ ફિક્શન ના મૂવીઝ હોય એવું બધું દેખાડે તો ક્યાંક ભૂલ નહીં થાય ને to make the movie more interesting, right? Okay, but we can recreate or we can think of a similar situation. Let's say you go on to space station, right? Okay, and from there, let's assume you do that, right? While you are doing a space walk, that is, you are outside the space station, maybe repairing something. You take a little pebble or a little stone and throw it towards the earth. So do you realize that due to gravity you will start falling down towards the earth from a huge height? Right? Space station is about 200 kilometers or more than that height above the earth surface. It is not that big compared to earth, but still quite high. So from that height, that is going to fall all the way down. So the bow speed was in there. Haven't we studied that if something is dropped from some height edge, so gravity will pull it down, and when it falls, its speed will become under root 2g using equations of kinematics. But acceleration is g. Correct or not correct? So like let's say you drop it from a height of 100 kilometers. The h is 100 add into 10 raised to 3. કેટલા 0 થઈ ગયા? root 2 into 1, 2, 3, 6 એટલે 3. So it will fall with a speed of 1.4 kilometer per second. Okay? But do you realize that when we do this calculation, we neglect air resistance? Yes or no? We neglect air resistance. So in reality, what's going to happen is that as it starts to fall, air resistance will slow it down. Speed at liberty, right? So what happens is that as it comes down, gradually speed will increase. Of course, it will increase, but then there will be a limit. The speed will not increase beyond that limit. Understood what I am saying? Why will the speed not increase beyond that limit? Because there is an opposite resistive force. Stokes' law. Make sense or not? As it tries to move down, there will be an opposite resistive force which will not allow the speed to increase. So finally, as it falls, after some time, let's say you drop it from here, after some time the speed will become constant. What's it? Understood? That is called terminal. Terminal means at end. That is, once it comes to that velocity, that's it. Now the velocity will not change. Check with your ages. Alright? Everyone? Okay, so till the end the velocity shall remain the same. That's why it is called terminal velocity. I think you understand terminal means at the end. Right? Okay. So, how much is this terminal velocity? That's what we are going to find. Right? So, let's divide. So, suppose that there is a fluid. Okay. let's say that there is a fluid, and in that fluid here is a small sphere. Okay, so first of all we are going to make FBD of it. It's falling down, that's why we are writing 3. So it's falling down, so downward force mg, that is its mass into g. ms, I'm writing ms, s for sphere. Alright, you understood why I'm writing msd? Right? Now, which other forces do you think would act on this thing? Which other forces would act? Buoyant force. Correct? There would definitely be a buoyant force because it is inside the fluid. Buoyant force will act in which direction? FB. Any other force? As it falls down, will there be any other force? There will be viscous. That's what we just mentioned, right? If there is some object that is moving in a fluid, whether it's air, water, oil, anything, right? So if it's moving in some fluid, there will be viscous force opposite to the direction of velocity. I hope you understand what I'm indicating here. The velocity will be down, so viscous force shall be opposite, right? Now this viscous force is, again, if it's a sphere, it is equal to 6 pi eta r v by Stokes. Why am I writing that value? I have a reason. I want to point something. Out of these three forces, which force depends on speed? Does this depend on speed? Mass into g. Mass का change not है. Fb, density of liquid, into volume into g. That's also does not depend on d. On me, sorry. This one? Yes. So let's see what's going to happen when this is dropped. Okay, suppose when the sphere is dropped, V is 0, and that's why Fv is also 0, right? But as gravitational force accelerates the sphere, have you understood what I have written so far? As gravitational force accelerates the sphere, Fv will increase, right? Fv will increase. Ultimately, it is after some time, Fv plus Fb will become equal to, I think that makes sense, or does it not? As it starts to fall down, gravity will keep accelerating it. That is, the speed will increase more and more and more and more. A point will come when speed is high enough so that Fv is also quite high, so that now Fv plus Fb become equal to, sure, you understood that? Again, the नीचे 100 suppose, ऊपर Fb ની value fix છે, let's say 5 મીટર. Starting માં Fv ની value 0, so it will start falling down. It will accelerate, so speed will increase. Speed વધતી જશે એટલે 1 2 3 4 5 6 95. So that 95, 100 नहीं 95. What will happen at 95? 5 and 95 together will make 100. So total force is total force is 0. That means acceleration is 0. That means speed is પછી speed changes. Understood? Clear? Again, at start speed is 0, so this is 0. So gradually as speed increases, this value will increase. A point will come where Fp plus Fb become equal to msg. So that total force is 0. Cancel. બધું cancel. Total force 0. Total acceleration also 0. Acceleration 0 means now the speed shall become right. Now, as sigma f external equal to 0, acceleration is also equal to 0. The sphere attains constant velocity or speed, which is called terminal velocity or terminal speed. Speed log the speed log the velocity log the one. Right? Both are fine here. Right? Last sentence clear? Okay. Everything will remain balanced. Then because we will not increase, Fv will also not increase. You know, sometimes people think that okay, Fv is continuously increasing. So પછી આ 95 ને 500 થઈ ગયો પછી થોડી વારમાં 100 થાય તો શું થાય? 100 નો થાય. Because it depends on speed. But speed is not increasing. So when it will be 95 but good thing. It's equilibrium. Right? Okay, so we are going to find out how much is that speed. Okay, when this attains maximum speed or the constant speed, how much speed is that? Okay. So one thing that we know from this FPD and from the sentences here, how much is acceleration? How much is acceleration? 0. So that means Fp plus Fv should be equal to msg. Okay, msg. Let's put all values. See, at that time this object is completely inside fluid. So buoyant force rho L V immersed. That's the whole volume, isn't it? Into G plus Fv's formula 6 by eta r V. Now instead of V, I'm going to write VT. VT for terminal is equal to msg. What is ms? Mass. But instead of writing mass, we are going to write density of sphere into volume of sphere into G. Understood? Rho s into V is nothing but mass. Clear? Finally, I'm going to separate VT. So only VT on this side. Everything else on the other side. Do you understand what I've done? In this term, that side, VG common, and then 6 by eta r. Now, what's the volume of this sphere? Volume of sphere, so yaad rakho joiye 4 by 3 pi r cube. જો નેક્સ્ટ ટાઈમ પૂછું તો વોલ્યુમ સરફેસ એરિયા બધું આવડવું જોઈએ. મેં તો એવું માનતું કે તમે મેથ્સ લીધું છે તમને તો આવડતું જ હશે, કોઈ ડાઉટ જ નહીં હોય એ બધી વસ્તુ. ઓકે, ડોન્ટ મેક સિલી મિસ્ટેક. So 4 by 3 pi r cube. What's cancelled? Pi. Ultimately we will get Vt is equal to 2 by 9. Here 2 cut 3 into 3 9. 2 by 9 rho s minus rho l into r square into g upon coefficient of viscosity. That's the formula of terminal velocity of a freely falling sphere. Don't use it for every shape. Use it only for a sphere. Right? बहुत बड़ी टर्म्स है कितनी मोटी पड़ती है. મને યાદ નહોતી રહેતી હું ભણતો હતો. ઇટ વોઝ વેરી ટફ. તો યાદ રાખવા માટે શું કરવાનું? કંઈ નહીં, 2-3 વાર ડિરાઈવ કરી નાખો પછી તમને ટેન્શન જ નહીં રહે. યાદ ન રહે તો કંઈ નહીં, આટલા સ્ટેપ કરી નાખવાના. આમ એક જ મેઇન સ્ટેપ ઇક્વિલિબ્રિયમ વાળો છે, પછી તો બાકીનું તો કેલ્ક્યુલેશન. રાઈટ? ઓકે, સો ધીસ ઇઝ વોટ. રાઈટ? હવે આની ટર્મ્સ લખી નાખો. VT for terminal velocity. Okay, start writing. ટર્મિનલ વેલોસિટી ઓફ what of sphere એટલું લખજો પછી તમે બીજા શેપ માટે યુઝ કરો vt is terminal velocity of sphere rho x density of sphere rho L density of liquid or fluid R for radius of the sphere G नहीं लो मत चाल से मोटा થઈ ગયો બહુ લખી નાખ્યું G બરાબર ને eta coefficient of viscosity of the fluid ठीक है હવે આવડી ગયો now right now you will be remembering all of these terms but મેઇન વસ્તુ એ છે કે એક વર્ષ સુધી યાદ રહેવું જોઈએ ને બરાબર ને અત્યારે તો યાદ રહે પછી થોડા ટાઈમમાં ધીરે ધીરે બધું ઉડી જાય ઓકે so that's about terminal velocity viscosity of air મને યાદ નથી જોવાનું હતું I forgot it. Otherwise, if I be remembering that value, we would have found out how much is the terminal speed of a raindrop. You understand what I'm saying? Right? A raindrop. Okay, and you can assume raindrop is almost spherical. It's not exactly spherical, but fine. You get a small error, no problem. બીજી બધી વેલ્યુ મૂકી દે એર ની ડેન્સિટી તો યાદ છે મને બાકી તો એક આ વેલ્યુ જ જોઈએ વોટર ની તો આવડે જ બધાને air ni I mean coefficient of viscosity temperature what is it 0 degree આપણે ચાલશે 0 degree ભલે ઠંડી હોય 40 है बुझे ना 40 डिग्री था 0.019 अच्छा ये बड़ी याद है I had to explain how eta depends on temperature तो भूली गया હવે આ પહેલા આપણે કરી નાખીએ પછી યાદ કરાવો છો પાછો ભૂલી ન દો Okay, so suppose you have to do it for a raindrop whose let's say radius is 1 centimeter. એટલો મોટો ન હોય raindrop હોય ને તો 1 centimeter radius. Okay, so let's say it's a raindrop whose radius is 1 centimeter. Let's put value Vt equal to 2 by 9. Density of sphere means water here. So water is 10 raised to 3 minus density of fluid through which that is falling. Raindrop falls through air. Air density is 1 kg per meter cube. Negligible है ना? छोड़. के लोगों 999 कट करो. बराबर है 999 into r square 1 centimeter square 10 raised to minus 4. G is 10 and eta is 0.019. 0.02 માં હું તો ભૂલ okay so now when we cancel this you get 100 here correct અહીંયા આને કેન્સલ કરો તો 111 so 111 into 10 raised to 2 plus 1 3 minus 1 so what's the maximum speed final terminal speed possible is 11.1 meter per second એનાથી વધુ સ્પીડ થી આવે ને raindrop if its radius is 1 centimeter, right? If it's even smaller, have you noticed that smaller raindrops fall slowly? Yes or no? Yes. Have you seen sometimes that when there's very very light drizzle, there are tiny water droplets floating around. It's a because their radius is so small that their terminal velocity is really very less. Correct? Compare that with a hailstone. You know what a hailstone? It would have a bigger size. Density तो बहुत फर्क ना हो. Water and ice, they have slightly different densities. Ice ni 900, water ni 1000, right? So they have different densities, but big thing. A size, right? The size matters. If it's R is more, double size was the speed 4 times that. You realize what I'm saying? And the khali etlu no problem to that. Double radius, speed 4 times. Okay. but mass is 8 times. Because if you think it's a sphere, sphere's volume is 4 by 3 pi r cube. The radius double line है, तो volume 8 times, the mass 8 times. Mass 8 times and speed 4 times. It's 32 times walking. You understand what I'm saying? This is a real calculation, no? It's not a joke. It is that if you compare two different raindrops, with one with radius 1 centimeter and the other one with radius 2 centimeter, so double no walking, 32 times walking. Right? It will hit you 32 times harder, because if it comes with 4 times speed with 8 times mass, its momentum is 32 times. Understood? And very soon it can become very drastic. એટલે ઘણીવાર લોકોને બહુ વાગી જાય when there are hailstorms. Right? આ 1 નું 2 કર્યું તો એટલો ફરક પડે. જે 2 નું 3 કરો એટલે પછી dangerous situation 27. Right? Okay. It will become 81 times. Right? Fine. So that's about terminal velocity of freely falling sphere. આનો એક experiment હોય. I don't know whether this year you all will get time to do 11th standard experiment. But you will have 12th night month time. Right? There is an experiment to find out coefficient of viscosity by doing this. You take a long tube filled with water and you drop something. And then you see after how much time it falls. Right? Or with what speed it falls. Anybody? I'm going to. Anyways, I'm going to erase it now. Graph draw કરાવો છે આનો. ના પેલા આજે ટોપિક ચાલુ છે પૂરું કરી લેવાનું. So V and T. Time, time છે our speed. So if you drop something, its speed will start to increase, but finally it will become, the graph will become flat. That is, now this speed is very close to Vt. Right? So this is the terminal velocity. What this means, listen to this. Pela slope વધુ હતું. Yes or no? Then gradually the slope will decrease. What's the reason? Slope indicates acceleration. Do you remember? Yes. Vt graph slope indicates acceleration. The starting acceleration વધારે. Because Fv, you remember Fv? Fv is small. Then gradually as speed will increase, Fv will also increase. So opposite force is more. So acceleration will decrease. धीरे धीरे करीने acceleration 0 થાય. Then you get terminal speed or terminal velocity. So that's what we have for this. આવો જ acceleration નો ગ્રાફ ડ્રો કરો હોય તો આનાથી ઊંધું આવે. Starting my acceleration g હોય. I have not drawn in the same direction. At start the acceleration is g and it will decrease like this. Finally acceleration will become 0. So you get terminal. આવું બધું આવશે તમારે મેથ્સમાં એવા ગ્રાફ exponential. Okay, now the relation of eta with temperature. So first of all, for liquid, પહેલા હું લખી દઉં પછી reason. As temperature increases, T for temperature, eta will decrease, and here we will write reason. And for gases, as temperature will increase, eta will also increase. આ એરો એવું થશે કે મેથ્સમાં increasing decreasing એવું આવે, sin is increasing ને cos is decreasing એવું નથી આવતું. કેમાં આવી ગયું આવું increasing. You haven't studied trigonometry yet in maths? તો quadrants માં ખબર તો હશે ને કે આ quadrant માં sin positive cos blah blah blah. And then along with that, don't you get that in first quadrant sin increases, For example, you go from theta equal to 0 to theta equal to 90, then from 90 to 180 it will decrease. That's good for me. Okay. તકલીફ એ છે કે ફિઝિક્સ આવડવા માટે મેથ્સ તો આવડવું છે બરાબર ને નહીતર તો કંઈ થાય જ નહીં. Okay, so here for liquids, if temperature will increase, eta will decrease. Now why does that happen? See, because in liquids mostly viscosity is due to intermolecular forces. And I'm sure you know that as temperature will increase, intermolecular forces will decrease. Everyone know that? Yes. And as temperature increases, intermolecular forces will decrease. So because of that, you know, if you think of the layers that we're talking about, one layer molecules pulling the molecules in another layer, but that force of attraction will decrease. So coefficient of viscosity will decrease. Fine, first one clear? Second, in gases, well, there is hardly any intermolecular attraction, isn't it? That's why gases are gases. Correct? So, in gases, when temperature will increase, intermolecular force, it doesn't play that kind of role. On the other hand, opposite. What's that? Do you know that in gases there is random motion? So let's say gas is flowing like this, okay, in some layer or in some part. So when the temperature is high, the random motion of molecules is more. In short, सीधा न चाले. એટલે આ આમ જતા હશે ને તો આને હળી કરશે. You understand that? That is between layers there are going to be intermolecular forces, but by collision, not like liquids where due to attraction they have a force, right? You understand what I'm saying? This is due to collision, and so basically higher the temperature, more random motion there is. It always the chemistry. At less temperature, the random motion is less pronounced, or it's less. It has less tendency of randomness. જેમ જેમ ટેમ્પરેચર વધે એમ મોલિક્યુલ ગાંડા થશે આમ ભાગશે ને આમ ભાગશે એવું આવે ને એનાથી આવતું કાઇનેટિક થિયરી ઓફ ગેસીસ તે આપણે પૂછ્યું છે જોવો ને તમને કેટલું આવડે એટલે મને ખબર પડે મારે કેટલું સમજાવવાનું બરાબર ને બધું એ જ આવશે આખી સ્ટોરી રિપીટ કરે કાઇનેટિક થિયરી ઓફ ગેસીસ તો સેમ જ છે ફિઝિક્સ કેમેસ્ટ્રી બે ઓકે સો when the molecules are going to hit each other, due to more randomness or more random motion, the viscosity will also increase. Because layers each other affect person. At less temperature, they will be behaving nicely. Okay, fine. As temperature will increase, they will push each other. Right? There are going to be forces. So you could say that here the important factor is random motion. Right? So as temperature increases, random motion increases, and that is why coefficient of viscosity also. These are two sentences of what happens in liquid, what happens in gases, and which reason. Okay, our question koi par puchi hai. They'll give you two substances. Like they'll say that A is liquid helium gas. And they'll say that B is oxygen gas. But A is liquid helium and B is oxygen, liquefied helium. So then they'll say if temperature will increase, viscosity of which of this will increase? Which of the liquidity? Then they give you options like helium and oxygen and both and none. Right? Okay, so that's what it will happen. So let's go to the next. That is surface tension. बराबर है कि नो करो? ये थाकी गया नहीं थाकी गया ना वो बात है surface tension. आज तो आई गई ना केमिस्ट्री में जाते करो रोज़ जाते करो उनको कम करो Okay. So first of all, surface tension is not a force. Generally, up till this moment, whenever we have been talking about tension, tension is a force. But surface tension is not a force. The name is weird, right? It is a misnomer, right? It's called a misnomer. Misnomer એટલે જેવું નામ છે એવું છે, right? Okay. So if it's not a force, then what is? To explain what surface tension is, consider that there is some beaker, like let's say there is water in it. Okay, and this is the upper surface, and we are watching that upper surface like this from okay, so I'm going to draw that. Here is the surface. With पानी से over the molecules है, and I'm going to do something magical on that surface. Okay, I will take this magical pen, and on the water surface I will draw a line. Needless to say, line is imaginary. So I have drawn an imaginary line on the surface of that liquid, or whatever it is, right? Liquid, it could be anything, oil, water, something. Let's say that this line has length L. Imaginary there, but it's okay. You don't have to do it for real. So let's say that this is a line of length L. Now what we have is, if you think that this is the international border, then on both sides of the border there are some parties or some particles, right? These are going to apply forces on each other. So surface tension is a relation. Okay, so listen to this carefully. So let's say these are some molecules, okay, of water or any other fluid, and on both sides there are so many molecules, and they are going to pull each other. Pull, I said, because it's a liquid. Gases do not have surface. Okay, I mean, if you think about it carefully, they do have, but it's very, 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 very small, right? So much that we can almost say that they don't, right? But liquids do have considerable surface. એના કારણે બહુ બધા જાદુ થાય સરફેસ જોવા છે ને કે નથી જોવા, તો કરીએ આપણે ક્લાસ. Okay, so these molecules pull each other across the line. So what is the definition of surface tension? That's what we are going to do. If you think of one particular molecule, let's say here, R, and it is across the line, this is the line, let's say, across the line it is being pulled in this direction, and there, and there, and there. There are molecules everywhere, do you agree? So in which direction will be the resultant force on this one? And even a resultant force, total force. અહીંયા molecule is pulling it, અહીંયા molecule is pulling it, અહીંયા is pulling it everywhere. Which direction would the resultant force be? Zero तो no आवे, I hope you realize. If you are finding it tough, let's say the line is like this and here is molecule, and the molecule is experiencing forces like this. Now it will be in which direction? Downwards, vertical, sure. Tilted draw કર્યું તો એટલે નહોતો. So you are saying that the total force on this is going to be in this direction, correct? At 90 degree to the line, yes or no? At 90 degree to the line, fine. Okay, now that's not just the case with this molecule. Even if you would have chosen the other one, same thing would have happened, right? Okay, so now this is the prompt time to write down the definition. Net force acting actually net intermolecular force. Net intermolecular force acting across and perpendicular to an imaginary line drawn on the surface of a liquid. Here I am not writing fluid because gases don't really play nicely. So an imaginary line drawn on the surface of a fluid. Before I complete the definition, this is not complete. Net intermolecular force acting across and perpendicular. Do you see that here? If you consider this as imaginary line, then this molecule is being pulled by the forces on the other side. Okay, from the other country. Clear or not clear? And that net force is in which direction? It is across the line and perpendicular to the line. Clear? So net intermolecular force acting across and perpendicular to an imaginary line drawn on the surface of a liquid per unit length of the line. Per unit length of the line is called surface length. અહીંયા સુધી તો એવું લાગતું હતું કે આ ફોર્સ જ છે, right? But like I said, it's not force, it is force per unit length. Okay, it is once again F perpendicular, but not like in pressure. There it was perpendicular to the surface. Here it is perpendicular to this imaginary line. Okay, F perpendicular upon L. The symbol of surface tension is either S for surface tension or T for surface tension. If T confuses you, use X because T is for tension. પછી T તો બીજી કેટલી વસ્તુ માટે આવશે, right? T for time period, T for temperature, જે આપણે બાકી છે ને thermal physics બધું, right? What do you think is the unit then? Unit લખી નાખો એટલે પૂરું કરી. What do you think is the unit of surface tension? Newton per meter, not Newton. Right? Again, it is not a force, but a force per unit. Right? It's not a force, but force per unit. Alright. Then we'll discuss other aspects of surface tension. Goodbye.